Hello and welcome back to another Unity 5 tutorial. In the last tutorial we started moving our UMA character around. So as you can see, our UMA using the NavMeshAgent is moving to a destination point. And the cool side effect we got using a NavMeshAgent is as we place our destination point behind this obstacle, our UMA will just move around, bounce a bit up and down, but he'll eventually find the destination. So this is pretty cool. But of course, this only would work now for inanimate objects. Anything where we don't need to have an exact realistic movement. So if you would have whatever in flying object that just has an animation like rotation or birds flapping their wings, but the animation actually doesn't contribute to the movement, then this would already be a pretty cool solution to get your object moving. So right now we're since we're fully using the agent, we're using the speed value, we're using the acceleration, and this gives us a smooth looking movement. But since we're not going to do that right now, at least, we have a character to move and we want to use the animation, we actually need to change that quite a bit. So I just want to keep this really short and simple as possible. I found a script online that does just what we want, the coupling between an animator and a NavMeshAgent. But I want to look at this script in another tutorial, and then we're going to adjust it to work with UMA. For now, we're going to write our own script just to get an understanding of how things work. We started with the script already, and there are a few downsides to the approach that I'm taking. So for once, we will totally ignore sideways movement. So instead of actually turning and using a turn animation, we will just use for now we have a running animation, so we will only use the running animation and adjust the rotation of our character. While this sounds like downside, if you have slow walking characters and if you have no steep ankles, or like if you're just doing like movements with not a with not a high rotation, sorry, missing the words here. Anyways, then this would look perfectly fine, and we're gonna try it out and you'll see the results and you'll be the judge of that if you can use it or not. But I think it's helpful because the approach is fairly straightforward and you can always refine it more. So the code we're writing now, if you're not happy with the results, just feel free to add some more things in order to get it more like what you want. But yeah, as I said, we're gonna still look into another script later on. For now, we write our own. So the first thing we need to do is check our animator. Since we're using UMA, we don't have an animator right away. It gets created or added at runtime. So first, UMA is rendering or putting together our UMA character using the recipe, and then our animator is added. And our update function would start running right away from beginning as we hit start. So we need to make sure to set our animator correctly. I'm going to do this in following way. If our animator variable is not null, everything is fine, we can go ahead. If it is null, we try to get an animator, and if we can get one, this we would set our animator variable with our animator component, and in the next loop this statement would be true. If there's no animator yet, this statement will be false, and whatever is in the brackets will not happen. Easy as that. So what do we want to do? First of all, I just want to give you a quick, really quick intro into an animator. So as sorry, you might not have this tab yet. So if you don't have the animator tab, just click on your test UMA, double click on locomotion, and it will open the animator window showing you your locomotion controller. And this one works with states. So we have an entry state which is idle, and we have a running state. Additionally to that, we have two parameters. As I said, in this tutorial we're gonna disregard direction entirely. We're not gonna focus on that, we're not gonna use it. Speed, however, is an important value. Basically what the animator does, it starts with the idle state, and here is a transition between idle and run with a condition. The condition says if the speed is greater than 0.1, we'll start running. Vice versa, if it's less than 0.1, will be idle. You can also preview those. That's the wrong one. Let's take this one from running to idle. So our character, sorry, that's slow-mo. Our character is running and he stops. So that's basically what's happening in case the value drops below 0.1. And if you double click run is not just a normal state, it's a so-called blend tree. And the blend tree does what it says, it blends states. So as you double click it, you can enter the blend tree and have a look what's inside. So here we have our blend tree with 3 states. And as you click on the blend tree, you'll see a matrix on the side declaring when which state is triggered. So this value is for speed. This is just always set to 1. And here we have the value between -1 and 1, and depending on what the direction value is like, the blend tree will choose the appropriate animation. So the last thing we need to note about our animator is that as we hit play on the run animation, we can see that the background is continuously moving, which means we got an animation with containing root motion. So our character, the object is actually moving. If you would open this up in a 3D modeling software and play the animation, then the entire body would move. The opposite of that would be in place animations. So then legs and arms and everything would move around, but the character's position would always stay the same. So here we got root motion, and this is important to know in order to decide how we deal with the animator in our script. Okay. Now what we want to do is we want our character to move, and as we said, we need a speed value higher than 0.1. So let's do that. Animator set float. I'm not fully sure. I think it's case sensitive, so you just gotta spell it correctly. So it would be speed, the value we want to adjust, and we set it to 1.0. And fair enough, our character is running. Now, I don't like it that he's just running wild like that. And so what we want to add is it's 2 things we're gonna add. I cannot entirely explain to you why it's now behaving like this, and after we've made the adjustment it's behaving differently, but let's just type it out and look at it. So I'm gonna set the agent's velocity to the animator's velocity. First of all, we cannot do it the other way around because this is a read-only value. Secondly, velocity, what's that? If you want a highly unscientific explanation, we've got here a character. he's moving in a certain direction. So imagine there would be an arrow pointing in the direction. So the velocity defines the direction, the angle, so to speak, and the length of the arrow, how fast. This would be kind of velocity. And what we want to do is we want to get the velocity from our animator and put it on our agent. So right now, before we've set this, our animator had the destination somewhere over here. So the agent has the destination over here and would set its velocity somewhat pointing over here. And as he moves around the corner, it would point somewhat over here. Now we take our animator's velocity, and all we've done with our animator so far is we've set speed to 1. And if you look in the plant tree, speed to 1, direction to 0 means we're just running straight. So I think it's always good practice to, before you hit play and try something out, to think what's actually gonna happen. So I hope, I'm not wrong here, but I hope our character will run straight, because we've now set the velocity to just run straight. Yeah, more or less straight. So again, I'm not entirely sure why it's behaving the way it is, but the main part is true. We're just running straight. So I think what we're gonna do now is we're just gonna adjust the transforms rotation. So instead of trying to fiddle around with the direction value and try to direct our character around here, I'm just gonna set the rotation using a value that our NavMeshAgent is holding. So this is a bit of, yeah, a hack, but it works. Or well, it's not really a hack, but it works. Anyways, let's look at it and then decide for yourself if this is something you can use in your projects or not. So we're going to use transform.rotation equals quaternion. Look rotation. So quaternion is used for rotations, obviously. And our agent has a value called desired velocity. To explain that quickly, we've placed our animator's velocity onto our agent. But even though our agent is now bound to walk straight-ish, the destination is still over here, and our agent knows that, and he's got a path over there. So the desired rotation points in this direction, because that's where he wants to go. He cannot do that since we've set the actual velocity to something else. So now what we're going to do is we're setting our character's transforms rotation to this desired rotation. And since that desired rotation must never be 0, we just need to do a check here if the desired velocity dot magnitude. We could also check for vector 0, but I'm just checking for magnitude now of the entire vector. If this is 0, then we cannot do this, since this must never be 0. Hope you can follow that. And now our character is actually walking around. So that works pretty nice, except for this jumping around at the end. So we need to put in another line. If agent dot remaining distance equals 0, then we just want to reduce the speed to 0. Again, there was the transition. If speed is smaller than 0.1, we will transition to the idle state. Let's test it, and there he is standing. So this is actually a really good start already. You can enhance the script. We're still gonna do a few minor changes, but feel free to try out things. I just want to point out the things that we disregarded or discarded. Oh, sorry, I'm not sure about the right word right now. Anyways, I just wanted to point out those things of that or the features our agent got that we just do not use. For once, our agent, let's look at our agent, got a speed. Now I'm just gonna go wild and I'm gonna set this to 1000. Not in play mode because that's not gonna keep my change. So I'm gonna set it to 1000 and now he should be running as fast as possibly can, but he doesn't do it. Why does he not do it? Because we entirely jack this speed value. We don't use it. We use only the animator's speed. So in this, there's the bell again. So always happens. Sorry about that. So we do not reset our animator speed to 10. And now let's just change that and take a public variable. Let's call this speed. It's a float. We call it speed and set it by default to 1.0. And let's use our speed variable down here and uncheck this one. Now we've got here a speed value at 1. So of course nothing has changed. Our character is still moving at the same speed. And so this speed value is not doing anything. Now let's take those 1000 and place them down here and just go nuts and run really, really fast. But that's not happening. Our character is still moving at a speed of 1. Why is that? Because all we're doing here is we're telling our animator, use this animation. So if we want to change the speed our character is actually running in, what we need to change is this value. I can show you, like at 2 he's running really fast, at 0.1 we got the slow-mo going. So how do we do this? I'm gonna keep it that way to have the speed set, because that's just good to know that our speed is greater than 0.1, so we will actually trigger the right animation. And this will enable us later on to switch between running and walking animation. But what we need to add as well is an animator.speed. So the animator contains a speed value, which is the value for how fast to play the animations. And we'll set this to speed. So now I need to undo my setting because 1000 would be far too fast. Let's set it at 5 to demonstrate it. He's already going nuts with 5, so that's already way too fast. So we looked at 2 in the preview, that looked still alright. Okay, so one thing we notice, this is too fast already, and we're also not hitting our endpoint anymore. The reason is because we're checking for 0 there, and the animation is too fast to hit exactly that point. So we gotta change that. But first, let's adjust our value. I just want him to run a bit slower. 0.7 sounds alright. So, and I want to change this to, excuse me, I want to change this value. Yes, we need to change this statement. So instead of checking for 0, that's, I guess, always something you want to avoid checking for an exact value. If it comes to something you cannot exactly plan or influence. So let's set a value here, 1.0. I don't know if that is too high. Just need to check it out. So of course what that will do is it will kind of create a radius around our point. And in this radius our character will stop moving. But I think that's fine. Assuming that you don't really need a precise spot for your character to be in. And now, as we look at our at the results, we've actually gotten quite far. We've got our character to move to a point. It looks all right when he's walking. Yeah, another thing we are. So this is the speed value, what I was talking about. Sorry, all over the place. So we are not using this speed value. We are now, with the changes made, using this speed value. But this one has to be fairly slow, fairly low values. So let's just adjust that as well. I don't want it to be just a float. I want this to be a range between, it must not be 0.1, because if it's 0.1, then our condition less than 0.1 in speed is not fulfilled. So I'm gonna set this to 0.2 at a minimum. And the max would be 2.5. That might already be in a saturation, but well, let's go all crazy here with numbers. Woohoo! Okay. Here we have our range slider. Let's check the min and the max value. Yeah, there we got the slow motion. That's kind of cool. So if you try to create a slow motion, this would be a way. This is again not so cool. Yeah, of course we could now get our drop zone larger, but I don't want to use an animation that's slow anyways, so this is fine for me that it's not working at the minimum. Now let's check the opposite in play mode, of course. And that one is working quite fast. So if you want to make a Bugs Bunny game, want your character to run really fast, this is the way to do it. Now, the problem is our idle animation is now also running at speed 2.5. We need to fix that because we don't want our idle animation to run that fast. So let's set our animator to speed to 0.0 float. And this, okay, I haven't tried that. This might actually fix our value. Oh, sorry, that was a mistake. To 1.0. We want our idle animation to run normal. So yeah, that works. Of course it doesn't look realistic, but again, we would probably choose a value something like that. So I was just thinking maybe now dropping the animation or adjusting the idle animation would help with our all the jumping around at the end. It does. It still doesn't look nice. So of course, if you have really low values, you would need to probably accelerate and decelerate a bit. And that brings us to the next point. In our NavMeshAgent, we got this value acceleration. But since we're setting everything, overriding all the values manually, this acceleration does nothing. So we could set this to 80,000. Yeah, sorry, that's just arbitrary value. And I do not want to have such a slow-mo. So let's have our character walk faster. So yeah, but the acceleration itself doesn't do anything. So this value can be, it's maybe good just to null those values in order for you to see that they are not doing anything. Okay, I guess this doesn't work to put in a 0. Sorry. Let's just find out which value it is. Okay, now it's not the acceleration. It's the speed value, which must not be null. Okay. That's interesting. But yeah, mustn't bother us, really. So now we're done with setting up our character. So our character movement with this script. I might still add acceleration, deceleration as we approach the target. Something like that would maybe make sense. And I might also add another animation. So right now we only have a run animation. I doubt that this comes in handy in any game to only have running NPCs. Depends on the game, but yeah, I think we need walking NPCs. So this is what we're going to do in the next session. Bring in another animation, smooth out the movement a bit better. And this will be it for my own movement script. And in the episode after that, probably, we will look into the Unity docs script. So I hope this helps you. I hope this is something you can use in your projects. And yeah, thanks for watching. See you next time.